Ah, video. Yeah, I'm sure it's going to be showing up. Yeah, there it is. All right. I just made a video testing, and it failed, of course, for a stupid reason. Wrong audio device. So, yeah. Anyway, so I just wanted to do a test video, really, but I wanted to do an explanation of, just how simple this whole thing is. I've sort of made this point that the whole universe is so easy to break down. So their theory lacks, okay, they give you bent space, no energy involved. So you're supposed to believe that all of the particles, all the sand, every little, I could break the earth into tiny little pieces of sand. Every one of them will be affected by gravity. Gravity affects little tiny things, the atoms inside of stuff. It doesn't affect just big things. So it's a nuclear force essentially. And yet this force, this effect, we have no accounting of it. We're just supposed to believe that every electron, every proton, and every bit inside of atoms somehow knows it's supposed to accelerate in a direction. That somehow it knows it. Again, giving abilities to things that just don't have ability. They can't figure out on their own where they're supposed to go. They're dumb little bits of stuff. They can't say, I know I'm supposed to go down. I'm supposed to go up. I'm supposed to go this way. I'm supposed to go that way. No, they do what they're told. Okay, that's all they do. And so I give you a simple, and then magnetism also. No energy involved. So this person, Robert Ritchie, well, anyway, he's making a video. Okay, I'll argue with him. If he wants an argument, he's going to get an argument. Um, but anyway, pointing out that there's no mass exchange. Yeah, everybody knows that. But I'm just saying, magnetism. Here you have this incredible force. It's obvious right in front of you. It happens right in front of you. You can just watch the stuff move around, do stuff. I can put two magnets on a stick, facing opposite, same poles facing each other, and they'll sit there and levitate for 10,000 years. They'll just sit there and levitate. Clear. I mean, it's obvious. Physics doesn't have any explanation. It won't tell you why that's happening. It'll give you nothing. No explanation why the atoms decide to do what they're doing. How do they do it? How do they know where they're supposed to go? How do the little electrons know? How do the protons know? How do the bits know? Because they have no force. It's just crazy, but that's true. And we know that all these forces move the same speed. Light, magnetism, gravity. All the same. Okay, and we know that it has one thing in common, that this little bits, little quantas of energy, essentially. And as I've pointed out, all you have to do is sort of think of it that way. There's two things in the universe. There's catchers, electrons, protons, atoms, more like atoms, but anyway. And there's things they catch. So there's little bits flying around, they catch the stuff. Alright, and what happens is something comes in, and they have like a little boat, and there's like 12 of them. So they have a little bit of reserve. Something comes in, they give back what the opposite of what came in, that be a reflection. Or they can catch it and keep it. Or more likely is between two of them, they'll catch it, give back the opposite, reflect, and then the other hand will see, oh, I got one, and it'll give back this, and then it'll go back here and do the same thing, and it'll just do that forever between two electrons. Once you got a force trapped between the two electrons, it'll just stay there like a ping pong ball between paddles. So you can think of it as catching, or you can think of it about like paddles and force. So there's ping pong balls and there's ping pong paddles. And if wherever the ball hits, it gives the paddle a little bit of momentum. If it's the same color force, if it's the same, if there's this to say there's red and blue ping pong balls and there's red and blue ping pong paddles. The electron proton, red and blue, force, red and blue. And so if a blue force hits a blue paddle, it reflects, sends out another one of these things. If a red force hits it, then it leaves perpendicularly. With that simple rule, you can create all kinds of high and low pressure and solve the whole energy problem. So, clearly, this drawing of a magnet won't be the drawing they'll show you, but this fits Maxwell's equations. This is what magnets are basically doing. They're creating plus, that is, I hate electrons. I'm North Pole energy, and I'm South Pole energy, and it's exactly how it's radiates from a magnet. That's how the math it works. It creates the depending on how how mixed it is. You know, I don't want to get too complicated. Obviously, you can see at the two ends, so it's a filter. That's all the magnet's doing. It's filtering energy that's coming in from the outside. So it's not generating energy. It's not making energy. It's not doing any of that. It's not even trapping energy. It's just a filter. It just says red energy go one way, blue energy go the other way. And that's all it's doing. It's just a filter. It doesn't make energy. So the external world comes in mixed, blue and red. The magnet filters it, red, blue. And once you've done that, then you can create the inverse effects, high pressure, low pressure. You can create attraction and repulsion really easy. Obviously, the Earth isn't a magnet, and the Sun's not a magnet. So they can't make the repulsive pressure. They can't create reflections that you would create if you had red end on red end. They can't do the reflection part. So all they can do is the attraction part. But the attraction really isn't attraction, because what's really happening is, as I've sort of pointed out, everything has a destiny, right? So let's say I trap a raccoon in my front yard. That raccoon would have had a history. You know, he had a destiny. He was going to go to my neighbor's house and get in the garbage, and then he was going to go screw a cat somewhere, and he was going to do some other shit. None of that shit's going to happen because he's stuck in a trap. And that's what matter does. That's what atoms do. Is the energy comes in and they trap it. Okay, it gets stuck between the electrons, essentially. That's the key trap. And it just stays there, going back and forth, back and forth, back and forth. It can stay there for 10 million years. Okay, and that's what happens to it. So the energy was going somewhere, like that raccoon, and instead of getting where it was going, it's stuck here in a trap, going like this. You know, it just keeps going around, or back and forth. Doesn't matter. And stuck there. It's stuck. So it's still moving, still going, still thinks it's doing something, but it's not getting anywhere. It's stuck in a cul-de-sac. It's just going around and around and around and around. It's just, you know, nothing. Same amount of up, same amount of down, same amount of this way, same amount of that way. It's just nothing. It's been neutralized in a sense by being trapped. But it would have hit something. So now something over here, right over here, is saying, where's my stuff? I didn't get my stuff. You trapped my stuff. I didn't get my raccoon. It didn't get here. But it's still got a bunch of other stuff hitting it from the back. Okay, so now it's going to move a little forward because it's going to absorb more stuff going this way than this way because it's getting hit with more stuff going this way than this way. So when it loads its traps, it's going to get more raccoons coming from this way than raccoons going this way. And so now it's going to move a little bit. That's moving. That's what gravity causes things to do, the moving part. And when it moves, what's it doing? Oh, it trapped the raccoons that were going to, you know, go somewhere else. So now these raccoons don't get over here, you know, these force bits. And so now this thing is saying, I'm not getting hit anymore. I'm getting hit with too little stuff. So it moves a little more forward too. And then once it moves forward, the other thing's going to say, I'm not getting my stuff. You know, so they're just absorbing force. So every time something moves, you have to see it as something that absorbed force. Somewhere, it trapped energy. Something, a bunch of energy came at it. It got trapped some of that energy, and that's why it's moving. Nothing's moving for no reason. Just the force bits, just the little tiny bits are doing that. And everything else is just a victim of it. So there's, you know, there's boats and there's cannonballs, okay? And you can catch the cannonballs, so to speak. And you own them until you give it back, and then you go the opposite way, okay? So whatever way you caught is what you keep for a while, and then you can give it back anytime you want to by just saying, by letting it go this way. By letting it go the way it was going, that you stopped it from going. So once you let it go back where it was going, then you'll go back to being neutral again. You know, you'll undo what it did to you by trapping it. Alright, so that's probably enough of a preface to play this a little bit. Yeah, and I mean, in the other video I went into more stuff because I'm just saying, you know, these comparisons between these two theories is just so obvious. Again, they have no energy for gravity, no mechanism, no energy for magnetism, two of the fundamental forces, and they barely have a mechanism for electricity. They don't call it anything, you know what I mean? They don't call the pressure, the voltage. They don't call it anything. They don't call the current anything. They just say it's like a stream. A stream of what? We don't know because it's virtual stuff. They don't have they can't account for where it came from. They don't know where the energy comes from because they don't understand energy at all. And the only bit they do understand a little bit is photons, because obviously photons are being ejected by atoms, electrons, and they're at a frequency. the little bits of energy. So the cannonballs are at a frequency, and they have to be created by a process to get those frequencies, so that we have some knowledge that there is something. But they're really the same stuff that is gravity, the same stuff that is magnetism. So if we could really see the little stuff moving around, zooming around at the speed of light, you would be amazed how much there is. We are in a sea of it. But it's nothing like an ether in the sense that none of the little bits are stuck to each other. None of the cannonballs are stuck to each other. They're all free cannonballs, and they never really interact with each other in any way that you could see. If I mean, I've already done this one so many times, but if they head-on collide, means nothing, because one piece of energy goes this way, one piece goes this way. So if they reflect, or they go through each other, or they miss each other, the universe looks exactly the same. So anyway, let's play some of this, and I'll just illustrate how. First, I'll illustrate how people pay no attention to videos. I mean, I say things overtly in my videos. I don't, how can they not understand when I say it in exact words? I mean, it's just amazing. I mean, I just don't understand how they can be so wrong.
But they're forming two magnetic systems, or two separate magnets.
Two magnetic systems.
Attraction, repulsion.
Yes, I know that.
There is no mass exchange.
Alright, so he just said there's no mass exchange. Where have I ever suggested there's a mass exchange in any other sense that, of course, the force has mass? It can't move something if it doesn't have mass. The cannonball you can't catch one, and it matters if it doesn't weigh anything. You can't have momentum without having mass. So there's kind of no point in saying it's momentum without mass. That's wooey angel talk or something. I don't know what that is. So in my system, there just wouldn't be any point in saying it's massless. Now, if you want to say a mass of 1, we're going to pretend is 0, we'll go ahead and do that. Okay, but that's pretending. Clearly, the force bits have momentum, and they give it to the matter bits. The matter bits catch it, and they move. And they can't move without them. It's like saying this fish in the school of fish don't have mass. Only the school has mass. That would be silly, in my opinion.
It's a field reaction. It's pretty simple.
It's a field reaction. It's pretty simple. What does a field reaction mean? Again, field of what? Alright, so clearly I've said it so 5 million times. I don't believe in the existence of any dead fields. So the only time there's a field is when your soldiers are moving toward the front. Then there's a field of soldiers. If there's no soldiers, there's no frickin' field. Okay, so the only way you can use the word field is to describe something that actually has energy in it. Actual stuff moving. If there's no stuff moving, it's not a field.
Field reaction. What should you think about that? No.
He wants me to think about it. I don't know what to say to that except fuck you. Fuck you, you patronizing kook. There's nothing to say about that. I don't need to think about this. I already have an answer, retard. Are you that far behind? I don't need your advice. I already have a model that works. Do you understand?
Mass exchange.
Clearly, it's mass, force, being filtered. Yes, there's no exchange in any real sense because it's all either reflection or deflection. The magnet never possesses any of the energy for very long, only when it's actually being moved. So when you actually change the field strength and the magnet has to move, it moves to a place where there's less field strength and it stops moving. So yeah, it only absorbs energy it needs to get away from more pressure, but once the pressure equalizes again, it'll be perfectly happy. But it's clearly filtering energy.
And yet we can exhibit force at a distance. Well, that's
Yeah, force at a distance, just like a light bulb, just like the sun, just like anything that radiates radiation. I mean, how clear, how much, I mean, what do I got to say to you to make you understand? I'm saying everything's being irradiated constantly by a bunch of invisible stuff moving the speed of light. For every photon, there is 10 trillion invisible photons doing the same shit. All right? And that's what's moving everything. Just think of how many photons it would take to move this thing 10 meters per second in any direction. It would take an insane amount of photons. And that's just illustrating a little difference in the amount of energy coming from the bottom from the top. So even that little difference is billions of times stronger than the strongest laser.
Spooky action. It's not spooky. It's quite explainable. It's quite logical.
Whatever.
We get under photons. I don't know why people have a problem with photons. Very simple. Some advanced concepts, but you can just look, if you just want a really basic 6-year-old's version of how a photon should be perceived.
Say the word.
It's a little packet of energy.
Meaningless.
Travels in a straight line.
Okay.
And as far as our solar system is the scale, if we just say within the solar system, it's a straight line. You know, leave all the rubbish out of it. Anywhere in the solar system, straight line.
It doesn't matter, solar system or no solar system. Straight line no matter where they are.
On A to B, straight line. I can't see what's so hard to understand about that.
So I don't even know who he's talking to here, but he's going to use the word wave somewhere, okay? Regarding 4x wave. There's no 4x waves that have anything to do with energy physics. They really don't. That's all atom physics, not the nuclear bits. All right. So anyway, I don't know what he's going to say, so I don't know if it's worth playing the video, and it's not really loud enough, so I have to change the settings and all that crap. So hell with it. So anyways, I think noon tomorrow, Saturday, Piro and the DeHilster guy are going to have a conversation about what, who knows, woo and wooier. So it ought to be pretty entertaining. So make sure you sit in a nice stable chair, just when it's LOL time. It ought to be a little bit funny. Just as to watch Piro lie through his teeth. Oh, that's a very interesting theory. When he doesn't think so. He's just gonna say what David needs to hear. That's all that's gonna happen. It's gonna be so disgusting. So patronizing. Anyway, till next time, and such. I think so, anyway. So at least it didn't crash. I just had. Today was not a good day. I had 2 hard drives in my hand, one to be copied and one to be copied over, and I somehow put it backwards, and just wiped out 500 gigs of data, and I have to, and I only copied over it with about 10, so I should be able to get most of it back, but it'll probably take me 6 years to get it back. And it's just so depressing. Ugh. But then everything, so I'm probably gonna have to live without a lot of things in a couple of months. So missing a little data, that should be easy compared to all the other crap I have to live without. So, just horrible to think about. I don't like change.